All right, so the other type of exponential function is called the decay function. The only difference, if you take a look at the function, we still have some base, so a is still greater than 1, but what's different is the fact that we're raising the a to a negative x power, not just to a x power. So that's obviously going to have a change in the behavior, the change in the function, but it's still considered an exponential function because the input is up in the exponent part. So we're still dealing with an exponential function. So let's see what happens. So again, to graph and look at the behavior, we'll do some point plotting. I'm going to pretty much still the same points that I did, or the same inputs that I did. And this time when I put in a -2, right, so we're going to have 2, and then we're going to take the opposite of -2, which becomes 2 squared, we end up with 4. So -2, 4 is on our graph. And then if I put in a -1, 2, take the opposite of -1, we get 2 to the first, and what we get is 2. Okay, so -1, 2 is on the graph. So you can already see the behavior being much different than the behavior that we had for the exponential growth function, because on this side, when x was negative, right, we were getting closer and closer to the x-axis, but this time it looks like we're on our way up. All right, putting a 0 in there, it doesn't really matter if I negate the 0 or not. We're still talking to the 0 power, which is 1. So we still have the same y-intercept, and then you can almost kind of anticipate what's going to go on, right? If this side over here is going to be going up, then I bet you this side will be getting closer and closer to the x-axis. But let's just take a look, right? Putting a -1, we get 1/2. And putting in a 2, right, we get 1/2 squared, which is 1/4. Okay, and sure enough, right, there's the half point, and there's the 1/4 point. So yeah, so then you can see that the decay function is slightly different than the growth function. It's almost like they reversed behavior. In this case, what will happen if we kind of maybe lose x as a time value, the thing we have is going down really fast, and then as time moves forward, it's getting closer and closer to 0. That's different than opposed to 2 to the x, whereas time went forward, we started slow and then sped up and got really fast. So definitely similar, but very different than a function. So as we saw, what do you expect the 3 to the -x power to be? Well, I expect it to be pretty much the same, right? 4 to the -x and 3/2 to the -x. So that's my expectation. How about, right, there's our gut feeling, but why don't we go ahead and figure it out or show ourselves that that's actually the case? So again, borrowing the same points, if I throw in a -2, right, we're taking the opposite of -2, which gives us 3 squared, we get a 9, right? We're taking the opposite of -1, that gives us 3 to the first, which gives us 3. 3 to the -0 is the same as 3 to the 0, which is 1. 3 to the -1 turns to the 1/3, and 3 to the -2 gives us the 1/9. So -2, we're up here at 9. -1, we're up here at 3, right? We still go through 0, 1, and then we're 1/3 and we're 1/9. So there's that behavior of this decay function. So it looks very similar to the one over here, just the points are slightly different. All right, so what do you expect the graph of 4 to the -x power to be? Well, it's going to be very similar, right? So again, let's just go ahead and plot the points to make sure we're, just good practice, but just to kind of verify what our gut instinct is saying. So again, oops. -2, -1, 0, 1, and 2. So 4, we're taking the opposite of negative 2, which becomes 4 squared. So there's our 16. We're taking the opposite of negative 1, which is 4 to the first, which is 4. Right? 4 to the 0 is still 1. And then if I put in a positive 1, right, 4 to the negative 1 becomes 1/4. And if I put in that negative 2, or excuse me, that positive 2, oops, we got 4. We get 1/16. And so negative 2 is way up here at 16. Negative 1's at 4. We're still going through 0, 1. We're 1/4, and then we're 1/16. So again, it's very steep, but it has that same action, right? So, oops, I keep doing that. Sorry, I've got to get used to my new iPad here. So, all right, so as x, so we see it has that different behavior that as x goes, if negative direction, we're on our way up, and if we're going in the positive direction, we're getting closer to the x-axis. All right, and so without any further ado, we expect the same thing to happen with this one, right? So when I plug in, let me put my points together here. So negative 1, oops, negative 2, negative 1, 0, 1, and 2. So 3 halves to the opposite of negative 2 becomes 3 halves squared. So we're going to get 9/4. Alrighty, 3 halves to the opposite of negative 1, right, is going to become 3 halves to the first power, which is just 3 halves. Anything to the 0 power is 1. And then 3 halves, we're taking the opposite of 1. And so we got 3 to the negative 1, 3 to the negative 2, excuse me, 2 to the negative 1. So we end up with 2/3. And then you can anticipate this is going to be 4/9. So I'm not going to bother with that one. So what we end up having, again, this is 2 1/4, right? So at negative 2, we're at 2 1/4. So about right there. At negative 1, we're 1.5. We're going through 0, 1. And then we're 2/3 and we're 4/9. So it has that same flavor, right? Where we're going up in, as x gets going to negative infinity, we're on our way up. And when x goes to positive infinity, we're on our way down. And so we call this type of situation exponential decay. And as we see with growth, it has some very similar attributes, except that the behavior is almost the reverse of what growth is. Rather than growing fast, right, we're decaying fast, if you would, and then getting steadily slower and slower to the x-axis in the positive x direction. So that's it, right? So how about we summarize these results in another video? I'll shoot that soon, and I'll talk with you guys in a moment.